Welcome. Today we discuss the new chapter Parabola of Coordinate Geometry. It is first part of Parabola. So first of all, let us see what is parabola. Definition of parabola is in a plane. Suppose there is a fixed straight line and a fixed point. That fixed point is S, say, and the fixed straight line is L. Now, if one moving point moves in that plane, in such a way that from its position, from any position, say P is the position, if its distance from the fixed point S and fixed straight line L, if these two straight distances are same, then locus of the point P is known as parabola. So actually, P is a moving point, S is a fixed point, L is a fixed line. If that point P moves in such a way that its distance from fixed point and its distance from fixed straight line, they are equal. Under this condition, the position, the locus of the point P, it will be a parabola. Under certain restrictions of axis, perpendicular is drawn from fixed point to fixed straight line and take it as x-axis. Suppose this is Z, foot of perpendicular, and midpoint between S and Z, it is at origin, then this become a y-axis. So if we take x-axis is that, y-axis is that, so a special arrangement of axis. In that case, equation of the parabola is y square is equal to 4x. xy we understand. What is xy? What is a? Suppose the fixed point I told you, it is S. This distance is A. On the other hand, say this is x-axis, this is y-axis. This is S. This is Z. Z means L. Then this is a parabola. This part is a parabola. Its distance of any point from S and its distance of fixed point L are same. Under this special arrangement of axes, I told you that its equation become y squared is equal to 4ax. So this is origin of the axis system. S, its coordinate is a, 0, and equation of that straight line, it is at a distance of a on negative side of x-axis. So it is x is equal to minus a, means x plus a is equal to 0. Now, this fixed point is known as focus of the parabola and normally denoted by a, 0. A means that A. This is vertex of the parabola 0, 0. This is equation of directrix, which is x plus a is equal to 0. And length of lattice rectum, it is actually a straight line passing through S, which suppose it meets the parabola at the point L and L dash, then the length, it is perpendicular to x-axis, then LL dash is called length of lattice rectum, and it is actually equal to LL dash is equal to 4a. This 4a base. Sometimes it is very useful to find the length of lattice rectum of a parabola. For that purpose, if equation can be put to that form, y square in left side and 4ax, coefficient of x 4a, it is the length of lattice rectum. Or if you can somehow find the value distance between S and O, the vertex, if this distance is A, multiply this by 4, that will give you length of lattice rectum. Or if you can find the distance between focus to equation of directrix, that length is A plus A, that is 2A. In that case, multiply this distance by 2, then you will get length of lattice rectum. Anyway, to find length of lattice rectum, it is very important for solving problems. Next, I discuss there are 4 other equations. One is y square is equal to minus 4ax. It is actually on left hand side of the y-axis. It is S, and equation of directrix is this. Its focus is at S minus a comma 0 and vertex is 0 0. Equation of directrix is x is, it is parallel to y-axis, so x is equal to a. Thirdly, equation x square is equal to 4ay. Its equation is of the form its vertex is this. This is focus. Coordinate of focus is 0, a. Equation of directrix is below that, below x-axis, and its length is, if it is a, this is again a, so it is equal to y. Its equation is y is equal to minus a, or rather y plus a is equal to 0. And lastly, one more, x square is equal to minus 4ay. It is its type is, its shape is like that. It lies all along on negative side of y-axis, negative side of. So its focus is S is equal to minus a comma 0. Its equation of directrix will be that is y is equal to a, and length of lattice rectum of all the 4 equations, y square is equal to 4ax minus 4ax, all are 4a. Next, there are, in our present syllabus, we have to face 2 more type of equation. of parabola, a parabola whose axis is parallel to axis of the x-axis, then its equation will be x is equal to ay square plus by plus c. A, B, C are unknown constants, and they can be obtained from other three given informations. Here, obviously, A naught is equal to 0. Otherwise, it will be a straight line. And one more, that is equation of parabola, which is, this is of that type, x-axis. So this one is, its axis is parallel to x-axis, and its equation is of that type. And one more I told you, whose axis is parallel to y-axis, like that. Its equation is y is equal to ax square plus bx plus c. A, B, C are unknown constants to be determined from given informations. Here also, A naught is equal to 0. Next one, equation of chord of y square is equal to 4ax, whose midpoint P, alpha beta, is, here y square is equal to 4ax is a parabola, first standard type. So suppose this is a chord of the parabola. If its midpoint P, midpoint of the chord P is given as alpha comma beta, then its equation is y beta minus 2a into x plus alpha is equal to beta square minus 4a alpha. It may help you if you try to keep the result in memory. This one, in brief, can be written as T is equal to S1. S1 means the equation in S1, in equation put x is equal to alpha, y is equal to beta, for a alpha beta square, this one. And T is tangent, equation of tangent. Equation of tangent at that point, how to find it out? It is actually for product terms like y square, you write it as y into y. It is linear term, you write it as x plus x, that is 2a into x plus x. For this term, y into y, put one y intact and other y is y coordinate of that is beta y. Beta y is equal to 2a into put one x intact and other x alpha, that is alpha plus x. This is technique for any conic section, circle, ellipse, parabola. Equation of tangent on it can be written always in that term. Just one more property I mention, that which is suppose This is a parabola. Y square is equal to 4ax. This is x-axis and axis of the parabola. S is the focus. Then it is a chord passing through focus. Then this one is called known as focal chord. Let it be say P S P dash. The property is 1 by PS plus 1 by this plus 1 by that. It is always equal to 1 upon A. A is that A. Base. Next, we discuss some problems. The focus of a parabola is 1, 1. And equation of straight line perpendicular to the axis and passing through the vertex is 4x minus 2y plus 2 is equal to 0. Then length of lattice rectum of the parabola. Let us see what is given. Suppose this is a parabola. I am not drawing axis. This is vertex. This is focus given as 1, 1. And a line perpendicular to the axis and through the vertex, this point, this is that. Its equation is this, 4x minus 2y plus 2 is equal to 0. Then we have to find the length of lattice rectum of the parabola. In standard form, y square is equal to 4ax. 4a is the length of lattice rectum. 4 times a. What is a? A is the distance between focus to vertex. Focus to vertex, that length is a. So this is a. From somehow, if we can manage the value of a from the given informations, then very easily we can solve the problem. It is actually equal to distance between focus this to that straight line to this. It means to that straight line. So our a is equal to 4 into 1 minus 2 into 1 plus 2 divided by root over of 4 square plus 2 square, 16 plus 4. So that it is equal to 4 by 20. 20 means 4 into 5, that is 2 into root 5. That is our A. So, without knowing the equation of parabola, we can obtain the length of lattice rectum is equal to 4 times A is equal to 4 into 4 in by 2 into root 5. That is 16, 8 by root 5. Oh, options are not given here. Actually, answer is options were 4, 8, 8 by root 5, 8 by root 3. So this is the correct option. So next problem. PQ is a focal chord of parabola whose focus is at S. PQ is a focal chord of a parabola whose focus is at S if P is 1 plus t square 2t minus 2 and Q is equal to 1 plus capital T square 2 capital T minus 2, then value of T into capital T is, options are 1, 2, minus 2, minus 1. For the parabola y square is equal to 4x, I just mention one thing, that is parametric form of the parabola. If we put x is equal to 8 square, y is equal to 2at, let us see what happens. This is y square means 4a square t square. 4ax means 4a into x means 80 square. So you see, by putting x is equal to 80 square, y is equal to 280, this satisfies the equation automatically. Then this one is x is equal to this and y is equal to 280. It is known as parametric form of the parabola. Here also, I draw it first. Here also, given one parabola is given, its focus, given that focus is S, it is given, and PQ is a focal chord. PQ, it is a focal chord, and parametric coordinate of P is this. This is x coordinate, y coordinate. Now Q also given. Then you have to find, but we have to find the value of small t into capital T. What would be that? Small t capital T. Options are this. So from parametric coordinate, how to obtain the equation of parabola in Cartesian form. For that purpose, let us take x is equal to 1 plus t square and y is equal to 2t minus 2. From these two, if we eliminate the parameter t, by eliminating parameter from these two, we get the Cartesian form. For that purpose, x is equal to 1 plus t square. T means y plus 2 by 2. From here you see t is equal to y plus 2 by 2. And it is actually x is equal to 1 plus t square. This is t, so t square. So that it becomes, this is 4. So 4 into x minus 1 is equal to y plus 2 whole square. This is the equation of the parabola, this parabola whose one endpoint of a focal chord is this. This is parametric equation of, this is Cartesian equation of the parabola. But you see, this is not in standard form. Our standard form is y square is equal to 4ax. In that case, our S means focus, it is a comma 0. What would be here? Let us see. Let us take x minus 1 is equal to capital X, y plus 2 is equal to capital Y. So this become y square is equal to 4a into x. This is almost of that type. So its focus is x is equal to a and capital Y and y is equal to 0. In that case, in the present case, our values of x and y are not small x, small y. It is capital X, capital Y. So capital X is equal to a. This is the x coordinate. It is x coordinate of the focus, and capital Y is equal to 0, y coordinate. Capital X is equal to small a. It means in that case small a is equal to 1, because 4x, 4 into 1 into x, so a is equal to 1. So capital X means in terms of small x, it is capital X is equal to x minus 1. So from there we get x minus 1 is equal to 1, that is x is equal to 2, and for y coordinate y plus 2 is equal to 0, that is y is equal to minus 2. So focus S is 2 minus 2. X is equal to 2, y is equal to minus 2. It itself a problem. What is equation? What is focus of that parabola? Anyway, we get that from parameters to Cartesian coordinate, we get the equation number 1, and its focus is such and such. So we get P given S is equal to 2 comma minus 2. We have to find a relation between T and capital T. Rub it first. It can be obtained from the fact that P, S, Q, they are collinear. Therefore, gradient of PS is equal to gradient of PQ. Gradient of PS, how much? It is P is this. It is actually equal to this difference, that y coordinate minus y coordinate. So it is equal to 2t minus 2 plus 2 by x coordinate is 1 plus t square x minus 2. That is, it is equal to 2t by t square minus 1. It is gradient of PS. Now gradient of PQ. Its y coordinate, all coordinate, x coordinate, y coordinate, all unknown. So gradient of PQ, it will be this minus that, that is 2t minus 2 minus that. Minus 2 cancels by x coordinate, this minus that. So t square minus capital T square. It is equal to 2 into t minus t, here t minus t into t plus t, capital T. Now this is gradient of PQ, this is gradient of PS, both are same. So we must have 2t by t square minus 1 is equal to 2 by t plus capital T. So 2 cancels. By cross multiplication, t into t plus capital T is equal to t square minus 1. So that t square plus t into capital T is equal to t square minus 1. So we get t small t capital T product is equal to minus 1. So fourth option is correct. Our next problem. A 2 3 and S 5 3 are vertex and focus of a parabola. PQ is its length of lattice rectum. PQ is its length of lattice rectum. Then area of the triangle APQ, how much? Options are 16 square units, 10 square units, 12 square units, 18 square units. Let us see what is the exact problem. For a parabola, its vertex is given and focus is given. And obviously, it is not given in standard form. And PQ is its length of lattice rectum. So without drawing axis, suppose this is a parabola. This is vertex A and its coordinate is 2 3. This is focus S. It is 5 3 and this is length of lattice rectum. It is PQ. We have to find the area of the triangle APQ. So from figure, it is clear that area of the triangle is equal to half into PQ base into altitude is AS. AS can be obtained very easily because A is given, S is given. So AS is equal to root over of 5 minus 2 whole square plus 3 minus 3 whole square, that is 0. So it is equal to 3. So AS is equal to known 3. It is known. And PQ actually length of lattice rectum. It is equal to 4 times A. What is A? A is the distance between focus and vertex. In standard form, you see, this is S, this is A, it is A, and it is 4A. So A is known now. A is equal to 3. AS is equal to A. 3 is given. We just now calculate it. So it is 3. Therefore, PQ, length of lattice rectum, it will be 4 times AS is equal to 4 into 3, that is 12. Hence, our area is equal to half into PQ means 12 into AS means 3. So it is 6, 18 square unit. So this is correct answer. Next. Next problem. Let P is the midpoint of chord of y square is equal to 8x, whose one end is vertex. Then locus of P is how much? Options are y squared is equal to 2x, y squared is equal to 4x, y squared is equal to 3x, y squared is equal to 6x. And now let us see what is the given problem. Here equation of a parabola is given and it is in standard form. Y squared is equal to 4ax A is our 2 here. So for the standard parabola, one chord is given, one endpoint of the chord is at vertex 0, 0. Suppose PO is the chord. Coordinate of P can be taken as AT square twice AT in parametric form. AT square AT square twice AT. A means and 2AT. So it is 2T square put T. This is obviously 0, 0. Its midpoint R is 2T square plus 0 by 2. It is 2T plus 0 by 2, that is 2T. Now we have to find, this is midpoint of the chord OP. R is the midpoint, this. We have to find locus of R. So from locus, we have to eliminate the parameter, unknown quantity. T is the parameter here. So let us take x is equal to t square and y is equal to 2t. From there, eliminate t. So x is equal to t square means y by 2 whole square. That is, it gives y square is equal to 4x. That is, this is the correct option. Y square is equal to 4x is the locus of midpoint of the chord whose one endpoint is origin. That is vertex. Okay, let us stop today. If you feel that this is helpful for you, please share it with your friends, like it and subscribe it. Okay, thank you.